A very good afternoon to all the participants. Today is the fourth day of our online faculty development program. So, our online faculty development program titled Recent Advances and Future Trends in AI and NLP. And this is our second session for today. Once again, this is Vidisha Bera, Assistant Professor of Computer Science and Technology Department. On behalf of Global Institute of Science and Technology, warmly welcoming you all on today's second session of our online FDP, organized by the Department of Computer Science and Technology, the NBA Accredited Department in 2022 of Global Institute of Science and Technology, Haldia, affiliated by the University of WBSCT and VE and SE and Macau. Today we have Honorable Speaker Dr. Shantanu Modak with us, and as a host of today's FDP second session, it gives me immense pleasure to introduce him with you all. Dr. Shantanu Modak, an Associate Professor and Dean of Research at Bengal College of Engineering and Technology, Durgapur, is a dedicated scholar in computer science. With a PhD from the University of Burdwan, his research delves into sentiment analysis and machine learning. Dr. Muduk's teaching interests encompass a broad spectrum, including data science, natural language processing, and Python programming. He has served in various academic roles, from assistant professor at St. Xavier's University to state-aided college teacher at Ashutosh College. Noteworthy is his prolific publication record, with contributions to reputable journals and conferences, and authored book chapters and textbooks. Dr. Modak's commitment to advancing the field is evident through his membership in professional bodies like the Indian Science Congress Association and his editorial board positions in academic journals. His expertise extends to organizing workshops and participating in faculty development programs on emerging technologies like artificial intelligence and machine learning. Dr. Modak's influence also extends beyond academia as he shares his knowledge through invited talks and webinars. Today's title of the talk is How to Initiate Research in Natural Language Processing. It is undoubtedly a very interesting and demanding topic for all the upcoming researchers nowadays. So now I would like to request Professor Dr. Shantanu Modak sir to deliver a profound talk on how to initiate research in natural language processing. So sir, over to you.
Thank you, madam. Am I perfectly audible?
Yes, sir.
Okay. Okay. So, very good afternoon, participant. Already, it's a brief introduction about myself, and my topic is how to initiate research in natural language processing. As it is a faculty development program, so I break the lecture into different parts. First, I will discuss what are the pre-processing steps of natural language processing. Means if we have some data in text data, so how we pre-process the data and then how to start the research in that field. Also, I will use some research gap in various fields of natural language processing. Okay, and the session is open to all. If anyone has any question regarding any part, just they can raise, and I can stop after 5 to 10 slides, so we can discuss about the research gap. Main aim of this talk is to spread the research gap and inform all the faculties about the research gap in natural language processing, so they can do some research for BTech level or MTech level or some PhD level, or they can do some research paper on that field. Basically, natural language processing is field of computer linguistic, computer science, and artificial intelligence, which generally process the human languages. Okay, from everywhere in current field, we got the application of natural language processing. So, what is linguistic? Linguistic means it's a solid understanding of the natural language. Means we can understand natural language, we know English, we can know Hindi or Bengali, we can understand the natural language, but if we create some algorithm that machine will be capable to understand the natural language, that is also one part of computational linguistics. Second part is machine learning. These are the basic of NLP research. Machine learning is also a fundamental component of NLP. Okay, if a computer wants to learn some pattern or make some prediction from the data, so machine learning will be helpful tool. And the programming language, basically several programming language are there, but as per my opinion, Python will be very popular language for NLP research. So when we want to start the natural language processing research, first thing we have to do the pre-processing. Pre-processing means, suppose if we want to analyze tweets from X handle. So tweets generally written in short format, or some emojis can be there, some punctuation mark can be there. So that are unstructured format. Means if we can, all of you already know that data can be classified into structured format and unstructured format. Generally, the text data, natural language data, that came in unstructured format. So to process an unstructured format data, some pre-processing tasks need to perform before the actual processing. So what are the pre-processing step involved? First thing is removing stop words. Let me discuss about the stop words. What are the stop words? Like DH, the, and, or. These are important in case of English grammar. But when we want to actual process data, these words are not so much important. So this word like and, the, is, or this type of word can be removed from the actual text data. And this part is called removing stop word. Next one is handling rare words. What are rare words? That are rarely in the data set, may not contribute to much in the analysis. So these words are very rare, that do not have any prominent contribution to the analysis. So we have to find that rare word, or we have to erase the, if sometime it not needed, we have to erase the rare words. And HTML tags and URL also need to remove, because in text data, if we consider some review from Amazon or Flipkart, or some data from X handle, there are several HTML tags and URL. So we have to remove the HTML tag and URL. These all are the pre-processing part of natural language processing. Now, the actual part, that is tokenization. What is tokenization? This is very similar to our compiler designing tokenization, that is part of lexical analysis of compiler. Means break the word into tokens. Sorry, break the sentence into tokens. Okay, but it should be meaningful. It should be meaningful. Like you can consider word as a token. Like if we consider this sentence, this is a token, this is another token, this is another token. So that can be token. Sometimes phrase can be also a token. Like combined of two word or combined of multiple word can be a token. Sometimes symbols can be a token. So tokenization is not an easy job. I have a text document, I break the text document into words, and it breaks the document into word by word. So it's not that actual tokenization performs. So tokenization is a very, very basic step of natural language processing research. Next one is normalization. Normalization means converting to a consistent format. So after tokenization, we have to convert to a consistent format. Means if I want to process all document in lower text format, so all will be converted to lowercase. Okay. That time this normalization, and in any one normalization start with small n, it will not be different. Okay. Both are considered the same if we normalize the whole documents. Okay. Next one is stemming and lemmatization. Both are almost same, but sometimes lemmatization gives the better result. Let me explain the difference between stemming and lemmatization. Both are used almost the same purpose. It removes the affix from the word and give the in the output it give the actual word. But sometimes stemming gives the wrong result. Means if we want to remove IES from the last part of the word, in stemming it directly remove the IES and return the word. And sometimes the word is not a useful one. But lemmatization is little bit different. Lemmatization compare the word with a dictionary word and produce the right one. So lemmatization takes little bit time than stemming, but it produced almost the correct result. Now come to the feature engineering part. So feature engineer first part is n-gram. N-gram means it's a consecutive word that took as a features. In pattern recognition, you also know a pattern can be a feature. In case of NLP, n consecutive word, maybe n value can be 2, can be 3, can be 4, can be 1 also. Okay, so n word, consecutive word can be taken as a feature, and that is called n-gram. Next one is parts of speech tagging. If we break the text document using tokenization, then we use the lemmatization to get the root word. When lemmatization applied, then goes will be converted to go. Then we have to apply the parts of speech tagging. It will tag every word. It can be noun, can be verb, can be adjective. So parts of speech tagging is helpful because if we want to get the sentiment score of every word, so we need the adjective and adverb. Not only for sentiment analysis, named entity recognition also need the parts of speech tagging, and other NLP problem also need the parts of speech tagging. Okay, so it's useful to handling the missing data also. Now, importance. What are the importance of pre-processing? First one is data quality. Means it ensures the text data is cleaned. If we complete the pre-processing step, so our text data will be clean, consistent, and free from the irrelevant information. So pre-processing is very much needed to improve the data quality. If data quality is improved, automatically performance will be improved. Means we can remove the noise from the data, we can extract meaningful feature from the data. Okay, and that will be efficient and scalable for our NLP model. Sorry. So there are several importance of pre-processing, but customizing pre-processing for different tasks means all pre-processing techniques are not needed for every NLP research. It's task specific need. Means if we want to classify our text document, but you can consider sentiment analysis also, but in case of sentiment analysis, data can be classified either positive or negative or named entity recognition. So some pre-processing steps are needed for sentiment analysis, some needed for named entity recognition. Every steps are not needed for every problem. It's basically a task specific need. Next one is iterative refinement. So pre-processing is not a single process, it's a iterative process where every steps are refined and adjusted based on the result and analysis. Okay. And also it is a domain specific consideration. Suppose if I want to analyze the financial data, it can't be same with medical data. Both are different. So customize, we have to customize the pre-processing tasks based on the domain. Okay. So I basically discussed these three type of NLP problem here and some research gap on this topic. First one is sentiment analysis. Sentiment analysis means it's basically used for product review, movie review, teacher quality review. Wherever the review part is considered, sentiment analysis is useful. It also useful for emotion. Okay, so basically it can be positive or negative or neutral. If we consider sentiment analysis as a classification problem, text classification problem, so our text data can be either positive or negative or neutral sentiment. So let me check. I think some message is coming. Any message? Okay. Next one is named entity recognition. It's useful to identify the named entity from the text. Named entity can be a people, can be an organization, can be a location. Okay, and next one is machine translation. Machine translation means it translates text one language to another. Okay, one language to another. So now I will analyze some research gap in sentiment analysis. So although it's a very crucial task in natural language processing, there are several research gaps are available. So if we can address this gap, it will be helpful for our further research, or if we can give the gap to our students so they can do some project on this topic. Okay, please. So, hello. 1 minute, 1 minute. Okay. So, sentiment analysis. First one is sentiment lexicon creation. So, what are the lexicon available? Researchers specially develop some sentiment lexicon for some dictionary. Okay, based on they can assign some polarity. Based on the polarity, it can be positive, it can be negative or neutral. Okay, so sentiment lexicon is a valuable resource for sentiment analysis tasks. Now, what are the research gap? It's domain specificity. Means every sentiment lexicon dictionary is not helpful for every research. It basically depends on the specific research problem. If we consider to analyze a teacher review, the sentiment lexicon will be different. If we consider a hospital review, that time lexicon will also different. Okay. Next one is multilingual sentiment lexicon. Means many sentiment lexicon are developed in English, but not in other language. If we consider the Bengali review, there can be other sentiment lexicon. Okay, so they give some difference in that. Okay. Next thing is fine-grained sentiment analysis. Means existing sentiment lexicon that are not very useful for fine-grained sentiment analysis. Existing lexicon can classify into 2 or maximum to 3 categories, like a positive, negative, and neutral. But if we apply the fine-grained sentiment analysis, there can be a scale. We can fit the lexicon to a scale like 1 to 5, or it can be very positive, slightly negative, very negative. Okay, so that is also a research gap. So if we can apply fine-grained sentiment analysis in sentiment lexicon, it will be helpful for further research also. Okay. Next one is contextual sentiment analysis. It's basically don't consider the contextual use of word or phrases. Okay. It actually needed for context-rich document like social media or online review. In social media or in case of online review, several review can come at a single point of time. So contextual sentiment analysis basically try to improve the accuracy based on the sentiment lexicon, handling sarcasm and irony. It's a very interesting task. Like if we consider he is a very good student, so this statement is a positive statement because good is there. So this statement can be a positive statement. But if we add something with that, he can't understand a single concept. That you can consider the whole sentence, no negative word are there, but the sense of the sentence is totally negative. This type of sentence is called sarcastic sentence. What a great book, I can't understand a single concept. This type of sentence considered as a sarcastic sentence. So handling this type of sentence is also a research gap because several research already done in this field, but still if we want to improve the sarcasm detection, this can be another research gap. Okay. Now, what are the model used in sentiment analysis? Specifically, we use the neural network and also use the deep learning technique for sentiment analysis. Recurrent neural network, convolution neural network, and transformer model all are used in sentiment analysis. Why we use neural network? Basically, neural network we use to analyze the complex pattern from the text data. But there is also a research gap in interpretability and explainability because deep learning model is not properly interpretable and explainable. So we can use deep neural network for improve the interpretability and explainability. So improving interpretability, this can be another research gap to analyze the complex pattern from the data. Okay. Next, handling the noisy and imbalanced data. One minute. Noisy and imbalanced data. So what are the noisy data? Any type of data analysis tasks. It can be raw data analysis, it can be text data analysis. Noisy data plays a vital role in every type of analysis. Okay. So every sentiment analysis model can struggle with the noisy data. Sometimes some pre-processing not done properly, some HTML tag can be there, some emoji can be there due to lack of use of pre-processing tasks. Several noisy data can present in the dataset. Okay, so noisy data also plays a vital role. Next one is robust architecture. Robust architecture means if we have the noisy data, so our training algorithm specially focus on the noisy data, so it will build a robust architecture. The model will not give the adequate result which we actually need. Okay. Next one is domain adaptation. So deep learning model, if we build a deep learning model for a specific type of domain, it may not be generalized to other. So deep learning model which we create for a particular problem, it will not be useful to other problem. This is another research base or research gap. Next one is transfer learning. What is transfer learning? It's basically enable deep learning model to adapt new domain. So domain adaptation is a problem in deep learning. If we incorporate transfer learning can enrich domain adaptation technique in deep learning model. Okay. Next gap is ethical and bias consideration. Any gap you can consider, and based on gap you can search research paper and you can start research in this field. Ethical and biased configuration. Every machine learning problem faced the biased data problem. Suppose we want to perform some image level classification. Either the image can be a girl image or boy image, but in our training data set, 90 data from boy image and 10 data from girl's image. So the data is a biased data. In that case, generally our model can't classify girl's image properly. So this is called biased data. So biased data problem is another problem. So if anyone want to do research on biased data or some ethical consideration on the data, that will also can be a project or can be a research paper on this part. Okay, so basically where we got the biased data in case of low resource language. Generally, major language like English, there are several resources available. Okay, but in other language like Bengali or Hindi, very limited resources are available. In Hindi, there are several resources also available, not like English, but in Bengali, very it's a low resource language in case of NLP consideration. Okay, so easily any researcher can start research in this field. They can optimize the deep neural network or deep learning model in sentiment analysis for low resource language. Next one is aspect based sentiment analysis. Let me explain what is aspect. Suppose we have this phone. So if I will purchase the phone from any e-commerce website, several features can available for this phone like camera, speed, network capability, screen type, all are the feature, and every feature of this phone can be termed as aspect. If we want to analyze a product based on all aspects, suppose the phone camera is good but battery is not good, so one aspect become positive, another aspect become negative. Okay, so aspect based sentiment analysis basically focus on the particular aspect from every topic. Okay, so aspect extraction is the main part of aspect based sentiment analysis, or in short term it called ABSA. First, we have to extract aspect from the text document or from the review document. So when we extract the aspect from the text, then we can start the aspect based analysis, ABSA. Okay. So after getting the aspect like battery, camera, and corresponding review word, review lexicon, sentiment lexicon, if we extract from that, then we can apply the sentiment classification. We can apply some dictionary for polarity justification in positive, negative, or neutral, whatever. And when we got the score of every aspect of this phone, we can summarize the opinion. So opinion summarization is also a part of aspect-based sentiment analysis. These are the total flow diagram how we can start aspect-based sentiment analysis project. First, we have to take the review from any e-commerce website. Then we have to extract the particular aspect and corresponding sentiment lexicon. Then we analyze the score or classify the score based on the sentiment lexicon dictionary, and we have to summarize the opinion. These are the whole process of aspect-based sentiment analysis. Now, what are the research gap in this page? First one is cross-domain and cross-lingual analysis. So basically, it's available, several research already done in this part in English language. But if we want to train on one domain or language, and we want to get output on other domain, that can be a cross domain. Suppose we train our model with a domain A, and we test the model with domain B, that can be a cross domain ABSA model. And cross-lingual, what is cross-lingual ABSA model? We train the model in one language and we analyze the document which are available in different languages. So cross-domain and cross-lingual ABSA can be a high research gap. And we have to apply the fine-grained sentiment analysis in ABSA. Already I discussed the fine-grained sentiment analysis, not just give the positive, negative, or neutral. We can fit a score like 1 to 5. That can be fine-grained sentiment analysis, and that can be applied in ABSA model. These are the very vital research gap in ABSA model. There are several other research gaps also, like aspect extraction accuracy. We can improve the accuracy of aspect extraction. It can be a research gap. Okay. Aspect level sentiment classification. Always it can't be give you 100% result, so we can improve the classification accuracy. And aspect based opinion summarization. So we can apply some opinion summarization technique to get the actual score. Now you can find that several e-commerce website already implement these things. So they analyze all the reviews available and they make a summarized code. So these are the opinion summarization technique. Now, what are the domain adaptation for sentiment analysis? First one is unsupervised domain adaptation. Okay. So it's basically adapt a model to target a domain without any label dataset. Means we don't have any domain label data. We have to directly apply the test set, and it's basically adversarial learning or self-training. So it can be a research problem. Okay. Semi-supervised domain adaptation means we have few label data to train our model. We don't have enough label data, we have few label data to train our model, although the existing method may struggle with scarcity and quality of label target domain data. Always the data is not available for a semi-supervised domain adaptation technique. Means every data not label, which data we got that are not label, always it's not label. So semi-supervised domain adaptation also can be a problem. Next one is cross-domain transfer learning. Cross-domain transfer learning means we train the model in one domain, we apply the test data which are from different domains. Okay, so there are several problem can be analyzed like feature distribution, label space. This can be addressed in a research problem. So what are the main research gap? First one is unsupervised domain adaptation. This can be one research gap. Semi-supervised domain adaptation, it can be another gap. cross-domain transfer learning gap. Next one is domain generalization. What is generalization? Generalization means if we want to create a domain which is a general domain, and I'm not expecting the 100% accuracy, but the model can be capable of almost every domain. So that can be a generalized domain. So if possible, this can be a vital research problem. And obviously the evaluation matrix and benchmark means already if someone do a research on a field and they got 80% accuracy and we build a model which give 90% accuracy, obviously it will be betterment of the existing research. Okay, now I will address another problem, that is parts of pitch tagging. Let me check any question is there. Okay. So parts of pitch tagging. Already I addressed the thing, parts of pitch tagging. What is parts of pitch tagging? Now, what are the research gap available here? Handling ambiguity. Ambiguity means there are several ambiguous words available in natural language processing. Like bank, BANK. It can be a financial institution. It can be a river bank. So handling this type of ambiguity can be a challenge for parts of pitch tagging. So already I discussed several research gap from sentiment analysis. Now come to parts of pitch tagging. So if we want to handle the ambiguity, what will be our potential solution? That is leverage contextual information, semantic knowledge, some deep learning model. Okay, by use some external knowledge, maybe can knowledge graph, maybe some ontology that can be useful to implement the model to challenge the ambiguity. Next one is handling morphologically rich language. Let me discuss what is morphologically poor language. Basically, English is called morphologically poor language. And what is morphologically rich? The language Hebrew is morphologically rich language. Although we don't understand Hebrew, but Hindi and Bengali is also called the morphologically rich language. So create a parts of pitch tagger which can handle the morphologically rich language. It can be a challenging task for NLP. Means if anyone want to create a parts of pitch tagger which can analyze the Bengali language or Hindi language, already several POS tagger available for Hindi and Bengali language, but we can improve the accuracy by importing some morphological analysis. Okay, so it also helpful for cross-lingual sentiment analysis or cross-lingual NLP problem. Means we train our model by one language and it gives output to another language. So handling morphologically rich language means creating tagger for this language can be another challenge. Okay, next one is cross-domain and cross-lingual parts of pitch tagging. Cross-lingual parts of pitch tagging, it may not generalize well to other domain if we create a parts of pitch tagger in English. Suppose we created a POS tagger which very much applicable in English, but it's not applicable in Hindi. So if we want to create this type of cross-domain or cross-lingual parts of pitch tagger, it will be helpful for everyone. Like if we create a parts of pitch tagger which trained by English language and it can tag the Hindi language, it will be a solution for every NLP researcher. Okay, so how to do this? Best for this, we have to use the domain adaptation technique. Sometimes transfer learning can be helpful, adversarial learning, data augmentation can be helpful. So it basically used for cross-domain and cross-lingual parts of pitch tag. Now low resource setting. Okay, so 1 minute up to this point, can you tell me if you have any question? If you have any question after this, you can ask. Okay. So, what are the low resource setting? Basically, POS stacking performance may degrade in low resource setting where label data are unavailable. Means we don't have enough number of label data to create a parts of pitch tagger. We have minimal annotated data which can be used for POS stacking. Okay. So what will be the potential solution? Obviously, we have to explore the semi-supervised learning. In supervised learning, we have several level data available, but in case of semi-supervised learning, we level data are available, but not much. We can use the transfer learning for high resource language, where several level data are available and transfer the knowledge to the for the low resource language. Okay. So it's basically developing the active learning strategy. Means it gather knowledge from one language and transfer that knowledge to another language. So already I discussed how to handle the noisy and imbalanced data. If we have noisy data, it will be not be very useful for a text classification model. So we have to use several data cleaning strategies, several NLP pre-processing tasks. First, we have to apply the NLP pre-processing tasks to remove the noise from the data. Then we have to make the data in a structured format. Then we can apply some data cleaning strategy to clear the data. But if we have imbalanced data, so class will be underrepresented. Okay, so it will be a very big problem in case of text classification model. So we have to create several techniques like oversampling, undersampling, cost sensitive learning that can be useful to handle the imbalanced data. Now, interpretability and explainability, which problem already I discussed. So, main challenge is deep learning model have achieved state-of-art performance in text classification, but lack interpretability. Means it difficult to understand how they make prediction. It gives the prediction, but it difficult to understand how they make the prediction. So if we create some interpretable text classification strategy, means how the decision making process done by deep learning model, it will be open to everybody. So that will be helpful. Means what are the potential solution? Obviously several attenuation mechanisms, several silencing maps and model distillation all can be the potential solution to address this issue. Means interpretability, explainability, these are the useful technique. Now come to the domain adaptation and incremental learning. These two are also text classification problem. Domain adaptation already I discussed in a previous slide also. Means it trained in one domain, but not it's a generalized domain. It adapts some data from the domain and it applicable to the other domain. Means if we create a domain specific technology, okay, so it can, suppose we trained the model using animal data. We train using some animal data. So it's adapt all the features from the animal data. Okay. So after that, the model can be applied for a particular domain. But something are common, means some sentiment word. If we consider the sentiment analysis, several sentiment word can present there. So if the domain can be a generalized domain and it adopts some sentiment word from a animal data set, that can be applied to another data set also. Incremental learning means it's continuously adapt to new data and concept over time. Means its learning phase is continuous like our human brain. Our human brain always try to learn from the new thing, and incremental learning, if we apply the incremental learning in machine learning, it will continuously adopt the new concept and especially dynamic environment, and it will categorize or it can classify new document in a better way. So just apply the machine learning technique is not helpful. If we can convert our model to incremental learning model, obviously we got more accuracy. Now we come to the end of this lecture. What are the metric used to analyze our NLP model? First one is accuracy. What is accuracy? It's basically specify the overall correctness of the model prediction. Then precision. Precision means my positive prediction current percentage. Okay, the proportion of the positive prediction that are correct. Actually, I discussed the difference between four metric here. Recalls means it's the proportion of the actual positive that are correctly identified. And you know the equation of everything for accuracy, precision, recall, and here I just mentioned the difference. F1 score is the harmonic mean of precision and recall. So these are the four metrics used to evaluate every model. And how to spread your research based on some collaboration. You can find some NLP journal, or you can attend some conference or workshop, or open source. You can follow some open source contribution like GitHub or any Stack Overflow where people are exchanging their knowledge. We can follow IEEE Explorer, Spinger like space where you can download some research paper and start research in this field. You can also make some interdisciplinary collaboration for the research. Like if we can add some linguistic people, they can be also a very good resource for our research. In several places of NLP, I find the linguistic people also part of the research team. These are the references which are used in this talk. Now I am come to the end of the session. Thank you. If you have any question, you can ask me. Yes, Dr. Uddalak Chakraborty. Yes.
Yeah, sir. Am I audible?
Yes, sir.
Madam, could you please mute your mic? It is echoing. Thank you. So my question regarding the talk that you have recently told about.
Yes, sir. Please.
Uddalak, it's not audible. Uddalak, sir?
Yes, sir. You are not audible. Can you just unmute your mic?
Uddalak, sir? Yes, sir. Yes, sir. Mr. Uddalak Chakraborty, sir, you are requested to unmute yourself.
Okay. Any other respected faculty member, if you have any question, you can ask me. Yes, sir. You can unmute.
Yes, yes. Okay.
Yes.
So, sir, I was actually talking that just in your recent talk, you have confirmed about the sentimental analysis. Generally, it captures the informal text of the comments of post, whatever maybe. So, does it clarifies any kind of thing which relates to image? Means in image, we something called have this depth precision factors and something like this. So in image, generally, how do we get this kind of spatial vectors or something like the parameter which will be definitely used for gathering those sentimental parameters as a byte?
Actually, it's a very good question, because if we want to analyze sentiment, text data is not always sufficient. Several emoji can be there, several image can be there. Suppose if I want to pick my image, it can be gives one type of sentiment about myself, about my mood of this time. So you can apply some image processing technique. You can create some image processing technique. You can apply some emotion recognition rule to analyze that type of sentiment. And emoji also, not only just image, emoji also tells the several thing about a sentiment. Like we know what emoji tells about the sad, about happiness, about cheers. So if we can train the machine using that emoji, machine can also give the result. Okay, sir.
Yes, sir. But sir, I'm talking emojis is fine. We will be getting the gestures and all. But in case of human face, like the face recognition, we will be having this kind of thing like contact detection and all, where only kind of depth, the precision is being acquired. Now, my question is that because I'm working in this field in computer vision, but I'm not getting any satisfactory related articles or something like that, which will be definitely giving me a
I
gesture
understand your
so
concern.
that I could get this precision factors. How it is being done, I'm not getting actually.
Yes, sir. You actually, the problem is for computer vision, means it's a face recognition problem,
Yes, sir.
and you want to apply the sentiment analysis in face recognition problem. I think this is your problem.
Yes, sir. Yes, sir.
Yes, yes, yes. For that case, I'm not very. I don't have any idea about how to apply the face recognition, but you can search. Uh, I think one journal is there, pattern recognition journal. You can find some paper there, because in pattern recognition journal, sometimes I find several papers which is which applied image processing as well as NLP technique. Okay, so if you want to analyze the pattern from face recognition, some pattern recognition journal or some computer vision related journal can be very helpful for you.
Yes, sir.
Okay, and
Yes, sir.
your research topic is very interesting. Very few papers are available in this field where emotion recognition and sentiment analysis from image data.
Yes, sir.
Okay,
Yes, sir.
so best wishes from my end.
Thank you, sir. Actually, it is a co interrelated topic of
Yeah,
AR.
yeah, it's a co-interrelated topic of computer science. Because computer
But
vision
sir,
is also part of computer science,
yes, sir.
sentiment analysis is also part of computer
Yes,
science.
sir. But I am working with correlation talking of this AR/VR, augmented reality and virtual reality.
Oh,
That
best
is.
wishes, best
Uh,
wishes.
Thank you, sir.
Uh, any other question?
Thank you, sir. Thank you, Dalok Chakraborty, sir. Anyone from participants want to ask any other question?
Any other question? If you, I will share the PPT with you.
You
Shall
want
we
to ask me?
benefit from collecting new or accurate data or creating new ML model? Let me see the question again. Shall we
Ma'am,
concentrate on
what
collect
was when will be the exam or something? Will there be exam or something?
new or accurate data or creating? Yes, yes, yes. Yeah, when you want to create a new machine learning model, first you have to think which learning phase you will consider. If you consider the supervised learning phase, obviously you have to collect the domain related document. Suppose if you want to apply supervised learning in product review, so you have to gather several product review to create your ML model, and that should be labeled. Okay, Joy Gorai. Joy sir, is it clear? But if we want to use the unsupervised learning, then label data set is not needed. We can use the clustering technique to do the unsupervised. Yeah. Okay. Thank you, Dr. Resmi. Definitely, I will share the PPT with the organizer. Nidisa madam, over to you.
Yes, yes. Thank you so much, Dr. Shantanu Modak sir, for enriching us with your broad knowledge areas on how to initiate, start research on NLP with sentiment analysis, fine-grained sentiment analysis, contextual sentimental analysis, aspect-based sentimental analysis, and different research gaps like noisy data, imbalanced data, biased or ethical considerations, cross-domain and cross-lingual ABSA, etc. So I hope all the participants and dignitaries gathered here have accumulated a tiny drop of his great wisdom and huge areas of knowledge from Dr. Shantanu Modak sir. So once again, thank you, sir, for spreading your valuable knowledge and spending a valuable time with us. So, sir, certificate for you as a short token of appreciation from our side on the behalf of Global Institute of Science and Technology. So, can you see it, sir, on your screen?
No, no, no. Till now.
Um, okay, sir, give us a minute.
Hmm.
Okay, sir. So this is the certificate for you.
Thank you, thank you, thank you.
Welcome, sir. And the attendance link for this session has been given in the chat box and in YouTube also in the comment section. Please check out there. And a gentle reminder of tomorrow's session for the participants. Tomorrow there will be two sessions. The first session will start at 10 a.m. and we will have with us respected Dr. M. Tanveer from Indian Institute of Technology, Indore. And we will have Professor Dr. Vishwaputi Jana from Vidyasagar University in our second session, which will start at 2:30 p.m. tomorrow. So all the participants are requested to join tomorrow's session on time, please. Once again, thank you all. Thank you so much, sir. And this is the
What,
end of the session.
what about the exam, ma'am? Will there be a
The exam link will be given after the end of the second session. Thank you.
Thank you.